Heat at the Amusement Park by Peyton Gabrish and Nick Brown. One day, little Joe was walking with his dad at the amusement park. "Dad, it's hot. Can we get some ice cream?" "Sure, son. Why not?" After a few minutes, Joe sees that it's melting in his hand. "Hey, Dad, what makes my ice cream melt?" "Well, son, it's all about heat transfer," his dad replies. "Heat transfer?" "Yes, heat is energy that goes from one object to another because of temperature difference," his dad says. "What is energy?" Joe asks. "Energy is the capacity to do work or supply heat," his dad replies. "And see, when you leave your ice cream out for too long, heat is going into the ice cream, which makes it melt. That's called an endothermic process. But when you freeze it, heat is leaving the ice cream, which makes it an exothermic process." "So what happens to the energy that leaves the ice cream? Does it just disappear?" Joe asks. "Good question. Energy can never be created nor destroyed. It just gets transferred from one form to another," his dad replied. "You mean there are other types of energy?" Joe asks. "Yes, of course, son. There's thermal energy, which is the one we just talked about, and 3 others." "What are they?" Joe asked. "Well, you see that roller coaster up there? When the car gets all the way to the top, it's just waiting to go down. It has a ton of energy that's just waiting to be released. That's called potential energy. And when the car finally does go down and it's moving fast, that's called kinetic energy, the energy of motion. The final form is chemical energy, the energy that can be released by a chemical reaction, but let's save that for another lesson. After a few minutes of thinking about all of this, Joe noticed the cup of ice water that his dad had in his hand. "Hey, Dad, I have another question. Why did my ice cream melt, but your ice in your water hasn't?" "Well, son, water has a specific heat of 1, and the ice cream has a specific heat of 5.5. Because water has a higher specific heat, it takes a longer time to heat up. We can find out how much heat it takes to melt your ice cream by using the formula Q equals mCp delta T. That means heat is equal to mass times specific heat times the change in temperature. So specific heat of your ice cream is 5 calories per gram degrees Celsius. The temperature went from 70 degrees to 40 degrees, and the mass is 20 grams. When you multiply all those numbers together, we see that Q is 300 calories. A few hours later, they were on their way home from the amusement park when Joe said, "Hey, Dad, I still don't really understand those endothermic and exothermic reactions you were talking about." "Here, let me use a graph to try and explain it to you." Joe's dad pulls out his phone to show him some graphs. The reactants are on the left side while the finished products are on the right side. See how in this graph the products have more energy? That means the reaction is endothermic. And here on this graph, as you can see, the products have less energy while the reactants have more. This means that it is an exothermic reaction. "Oh, I get it now," Joe exclaimed. "Thank you so much for teaching me all of this," Joe said. "Don't mention it, sport, and remember this stuff I taught you is called thermochemistry. To put it in simpler terms, thermochemistry focuses on the heat changes that occur during a chemical reaction or change in state."